Okay, here in 2.5 we're going to be taking a look at rational expressions and equations. I've taken a look at the objectives. We have 5 simplifying rational expressions. That's just reducing them down. Combining rational expressions, that's using addition, subtraction, multiplication, division in order to combine them. Simplifying complex rational expressions. As soon as you see the word complex, you want to think more than one. So we're going to have more than one fraction involved, a little bit more complicated ones, and we'll take a look at those. And then we'll take eventually a look at solving rational equations and actually finding some solutions. A very lasting interlude is to work rate problems. You'll have a few of those where you can see an application of these rational equations and expressions. Now, what is a rational expression? Well, rational expression, first off, the word rational, if you just sort of take a look at it, has the word ratio in it. And that means really it's a comparison of two numbers, and what we're dealing with is a fraction. So a good way to remember anything that's rational is just really tie the word fraction with it, and you have a pretty good chance of understanding what's going on. So if you think of like rational exponents, those are exponents that are fractions. Even our rational numbers, yeah, there is a formal definition, but there's a good way of remembering if be written as a fraction that's either terminating or a repeating decimal. Now for polynomials, what we're going to take a look at is it's going to be P over Q, where P and Q are both polynomials. But specifically, Q cannot be 0. We can't divide by 0. Worlds collide. We have to avoid that at all costs. But we also want to make sure that Q has a variable involved. If the numerator is the only thing that has a variable and the denominator is just a constant, we're not talking about a rational function anymore, where Q needs to have a variable, just like the two examples down at the bottom, whether it's a variable in a binomial or whether it's a single-term denominator. That's what makes it a rational expression. Okay, so to simplify rational expressions, you want to think more of like a fraction. And so how do we simplify fractions? Well, we can reduce fractions. Let's, for an instance, look at like 4 over 8. That's a fraction, so that's going to be similar to what we're going to be dealing with. And how do we reduce 4 over 8? Well, technically what we do is we factor 4, or break it down to its primes, and we do the same thing with 8. So, and again, what we're doing here numerically is a factorization. Once we get to that point, now what we can do is look for common factors that we can remove from the top and bottom. They cancel each other out through division, and so we get that. And technically what we have left is there's a 1 up there, and then we have a 2 on the bottom, and that makes sense. 4 over 8 is the same thing as 1/2. We haven't changed this value. We've just simplified it. With polynomials, it's not going to be much different. We've been looking at how to factor here recently, and so that's going to be a key. And a lot of times I'll call it the triple F effect. And so you've got the F, 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 which means factor fractions first. And so anytime that you have fractions, you want to remember really to factor as much as you can. You'll factor at the beginning, sometimes you'll factor in the middle, and you'll factor at the end. There's a lot of factoring going on, so hopefully you can review some of that as well. And all those factoring things are found back in Chapter 1 if you would like to review those. But what we're going to do is we're going to factor both the numerator and denominator and see what they're made up of, okay? So that we can remove any common factors. Now, once we do that, there are some things that we've got to consider. There are some values that will make this fraction undefined. If you remember, by definition, the bottom cannot equal 0. So once we factor, if you come down here to the bottom, let's say we factored the numerator to be AC and the bottom to be BC. Here's our factors, BC, and then on the top it's AC. So you can see where there's a common factor on top and bottom of C. But before we simplify, what we need to do is once we factor, we need to identify where this fraction is undefined. In other words, what I'm saying is where the denominator would equal 0. So before we simplify, set the BC equal to 0. Use your zero factor property. Set both factors B and C equal to 0. And look, B cannot be 0, C cannot be 0. We have to identify the undefined values, especially when we get to solving, because there are going to be solutions that don't satisfy the original rational equation, and we have to identify those. So the best way of doing that is to do it before you cancel. Once you factor, then set the denominator equal to 0. That's going to allow you to identify where the denominator is undefined. Or where the expression is undefined, where the denominator equals 0. Now, once you do that, then we can look for common factors on top and bottom, a vertical cancellation. When we get to multiplication, you'll probably sort of already have an idea of what we're going to do there. We're not going to do just vertical, but we can also do cross cancellation to simplify an expression. But once we remove the c, our simplified expression is a over b. However, it's still undefined where c equals 0. So whatever value makes that factor 0, the c factor, we have to exclude it as part of the solution set if we're solving. Okay, and so we'll look at some of those. First one here, sort of, I went step by step for you, and then what we'll do is we'll look at some where you can pause and take a look at yourself without the answer just being in front of your face. So if you take a look at this problem, we have x cubed minus 27 over x squared minus 3x. So it's a fraction. What do we do first? Well, it's the triple F. Factor fractions first. Factor, factor, factor. You want to factor as much as you can. So x cubed minus 27, well, that is the difference of two cubes. If you remember the templates we worked on, that expression right there will fit in this template. What goes in here is our a is x, and what's going to be our b is 3. And so if you remember, it goes little bubble, big bubble. Then it goes keep the sign, so whatever sign's there, we keep it. Change the sign, always plus. Then it goes a squared, ab, b squared. And so just some of that review of factoring of a difference of two cubes would come in handy. If you look at the bottom one here, what we have is we have two terms. Now, what do we always look for first when we factor? Hopefully you're thinking GCF. That's always what we look for first. The numerator didn't have a GCF, but the denominator does. There's an x that's common in both these terms. So we're going to factor out that GCF and leave behind an x minus 3. Now before we go any further, let's identify where it's undefined, because we don't want to simplify before we identify the undefined values. So those are called discontinuities. And there's really two types. You don't need to know the two types, but there's removable and non-removable discontinuities. Removable are obviously ones that we can get rid of. Non-removable will be there forever. So here what we have is we actually have both of them. Let's go ahead and set our denominator equal to 0. So I'm right over here. I'm going to take our product and set it equal to 0 to identify what makes the denominator 0. Well, zero factor property says x cannot equal 0, and then x minus 3 cannot equal 0, which means x cannot equal 3. And so what we have is we have these two values that are undefined, and you can see that as part of our solution over here. Our simplified expression is that x cannot equal 0, 3. At the very conclusion, you can definitely see why x can't be 0, but notice we lost the 3. There's nothing down here. We can actually plug in 3 here. 3 is actually what they call a removable discontinuity, and it's actually a whole. It wouldn't be a vertical asymptote like 0 would be. 0 would be a vertical asymptote, where 3 would be a point discontinuity. But 3 is still undefined in the original, and that's the key. What's undefined in the original expression? So we've identified where it's undefined. Now we can go ahead and reduce. And what you'll notice here is what factors are similar on top and bottom. Well, x minus 3 and x minus 3 are common on both top and bottom. So we can remove them from the problem to simplify it. If you remember when we talked about the difference in sum of two cubes, don't waste your time. The big bubble will never be factorable. Even if it looks like it can be, it will never, ever can be factored. So what we have is we have x squared plus 3x plus 9 all over x. And that would be an appropriate way of putting an answer. Maybe another way of putting it is, notice we have what we call an STD, a single term denominator. And how do I treat an STD? Well, what we do is we stack and we simplify. Okay, that's how you get rid of an STD or treat it. And so we can go ahead and we stack, and then we are looking to simplify if we can. I'll put a 3 there instead of an x. Let me change that. And so what we have here is on the first one, you can cancel that down to an x. The second one, the x's are gone. And then the third one, you can leave it 9 over x, or you can write it as 9x to the negative 1. So there's a few ways you could write your answer. And so you may be wondering, well, how do you want the answer? Well, really all three of these would be appropriate ways of, or this way, and then with the x on the bottom, or this way. And this would be fine as well. And that way you can see the fraction definitely being applied there. Let's go ahead and move on to another one here. If you look, this one, if you want to pause and give it a shot yourself, that would be appropriate. This one's a little tricky in the denominator, so you may get stuck down there, but first things first, it's a fraction. What do we do first? Well, we factor fractions first. And so we look at the numerator, and it's a trinomial, and so I'm going to go to my double bubble, and this one's going to be a shortcut because the a is 1, so I put my variable in. I want to find factors of negative 15 that add up to negative 2, and it'd be negative 5 and positive 3. So I slap those factors in here. My a is 1, so it doesn't change anything on my bottoms up. In the denominator, now this is where it gets a little tricky. Hopefully you recognize this is x minus 5 This is 5 minus x. Those are not the same. They look very close, but they're actually complete opposites. What else could I factor out, maybe on the bottom, that would make it look like this? Well, if you notice that we could factor out a negative 1. If we factor out a negative, then what that does is it makes the x positive and the 5 negative. And so the x becomes positive and the 5 actually becomes negative. Now our bubbles match up, and that's going to help us in just a moment. And so that's something that you really want to look for, is factoring out a negative. And so this may put something in your notes you want to put factoring out a negative, because that may be something that you're going to want to reference as you go through these problems, because that will trip a few students up if you don't see the factoring out of a negative. Sometimes it works, sometimes it doesn't. In this case, it will. Now, before we go any further, let's make sure to identify where it's undefined. I set the denominator equal to 0. So this is the denominator. You can set this one as well, but I'm going to set the factored one. And so what we have is the opposite of x minus 5. I set that equal to 0. Well, I can multiply both sides by a negative to get rid of that negative. And then I simply add 5. And what I notice is that x cannot equal 5. So I know where it's undefined, it's at 5. So really the question is, can I simplify? We can only cancel factors, not terms. And that's a huge thing. And that's going to, on the slides here is coming up, I'm going to show you an example of what's canceling terms, not factors. Here we're going to cancel the factor x minus 5. Factors are bubbles. It creates a product. Okay, and so those two are considered factors. Now what I'm left with is x plus 3 on top, and a negative 1 on the bottom, and that's not probably ideal for how we write our answer. Nothing wrong with this, it's just not proper. Maybe what we should do is go ahead and do this negative on top. It's a lot like if I had 4 over negative 1. What is that the same as? Well, it's the same as the opposite of 4 or negative 4. So we can bring that negative to the top. You just got to make sure to share it, and we get the opposite of x minus 3. Where x does not equal 5. And if you take a look at this final answer, we would have the exact same answer there. Okay? And so factoring out a negative will come into play once in a while. Keep an eye out for that. Now notice, remember I just mentioned that there are some things that may trip you up if you're not careful, and that is we cannot we cannot cancel terms. We can only cancel factors. And so there's a caution here that when we have something like this, let me move these cancellation deals real quick, if I can grab them. I might not be able to grab them, so I'll go ahead and rewrite it right here. X plus 4 over x squared. If you take a look at this, what I did to show you sort of what you can't do is this is a term, and that's a term. Now, how do we know those two are terms? It's connected by this plus sign. And so terms are connected with addition and subtraction. Factors are connected with multiplication. So x is not a factor, it's actually a term. I cannot cancel terms. I can only cancel factors, which are bubbles, products. That's all I can cancel. So no factor, no cancel. So here, if I try to do something like that, I'm doing something illegal in math, and obviously the answer of x plus 4 over, 4 over x is incorrect. Really, the correct answer is really simplified, and that is the x plus 4 over x squared. You can't go any further, because if you cannot factor, you cannot cancel. So that's a good rule of thumb. If you sit there and go, can I factor x plus 4? And you say no. Can I factor x squared? No. Unless those are the same things, you cannot cancel. So be very careful of that. You can only cancel factors, not terms. Okay, moving on. Combining rational expressions. So now we're going to be doing some operations here. And so the first operation that we have is addition and subtraction of two rational expressions. And then we'll look at multiplication and division. Now, if you can reference what you did with fractions, you should be in really good shape. Remember, for addition and subtraction, the key on addition and subtraction is to get a common denominator. I mean, that's it. That is the whole point of that, because the only way to add anything, really, variables or fractions, is they need to have the same last name, is what I call it. And so 1/2, I have 1/2 is what I have. If I'm adding that to 3/4, I have 3/4 is how many I have. It tells me, the top number tells me how many I have, the bottom number tells me its name, and so its last name is half and fourths. Those are not the same last names. I cannot combine these until I make the last names the same. And so in this case, I got to make the 2 a 4. Whatever you do the bottom, you got to do the top. And this is how we would end up adding is straight across the top. It's like squishing it together. So you'd have 2 plus 3 all over that last name. Last name doesn't change. With fractions, when you add or subtract, the last name doesn't change, or the denominator doesn't change, is what it is. When you multiply, all you got to do is multiply straight across the top. So if you're multiplying two fractions, you're going to multiply straight across the top and straight across the bottom. And then you might want to reduce. Now, another method is, if you have a fraction times a fraction, you can actually look to cross cancel. whether it's there or this way. So you can vertically cancel and you can diagonally cancel. So you can cancel up and down and you can cancel diagonally. You cannot cancel horizontally. There's nothing like that. We multiply horizontally is what we do. And then division. When we talk about division, really we don't divide really fractions. If you remember back just with numerical fractions, we don't typically divide. What we do is we multiply by the reciprocal. What's that mean? Keep it, change it, flip it. We keep the first fraction, we change the division sign to multiplication, and then we flip the second fraction. And so what we have is a keep, change, flip. KFC, sometimes teachers will refer to it as that. Keep, and that's K is for keep, and then the KF is for flip, and then the C obviously is for change. But however you want to remember, technically it's going to be multiplied by the reciprocal. Keep it, change it, flip it. No matter what operation you're considering here, all these different four operations, remember that with any kind of fraction, what we need to do is we need to factor first. Factor the numerator, factor the denominator, and then you can proceed with whatever operation you may be considering. So let's look at a subtraction. Addition is going to be very similar. I think subtraction is probably the harder of the two, to be honest with you, because there may be a distribution of a negative that we tend to forget sometimes. So what we have is we obviously have rational expressions because we have fractions with variables in the denominator. So first things first, factor fractions first, triple F. So I look at 5x minus 2. That's prime. There's nothing there. There's no GCF. There's no difference of two squares. The bottom can be factored. It's a shortcut trinomial. So I want to find factors of 6 at -5. Now this is a 5-6 combo, so you want to be careful because you can use 6 and 1 and 2 and 3. In this case, you're going to end up using -2 and -3. They multiply to be 6. They add to be -5. So be careful with the 5-6 combo. That gets students occasionally. Over here, the denominator is the difference of two squares. So it goes x plus 2, x minus 2. If you remember our templates, something squared minus something squared goes to a plus b, a minus b. And so that's something that we talked about in earlier sections. And again, you can reference chapter 1 if you have some trouble with that. And then the top is just 2x. So what we have now is we can identify where it's undefined by simply setting each denominator equal to 0. And so I'm going to have x minus 2 equal to 0 and say, oh, x can't be 2. And then I set x minus 3 equal to 0 and say x cannot be 3. And then over here, I already did x minus 2, so I don't need to do it again, but I can do x plus 2 equal to 0. Technically, it doesn't equal that. It would be -2. So I have three values that x cannot equal: 2, -2, and 3. So if I was solving this and I got any of those three, I'd have to exclude it as a solution. Now what we want to do is we want to create common denominators because they're fractions I'm trying to add or subtract. I've got to be able to squish them together. They have to have the same last name. Now what we currently have in common is an x minus 2. But notice this one has an x plus 2. This one does not. And so what I do is I go, okay, well, I'm going to multiply the bottom by x plus 2. And whatever I do the bottom, I got to do the top. And so now all of a sudden they both have an x plus 2 common. This one has an x minus 3. This one needs an x minus 3. Whatever you do the bottom, you got to do the top, not to change the fraction. Because technically what we're doing is we're multiplying by 1 if you look at that. So that doesn't change anything. Once you get common denominators, now what we want to do is we want to squish these together. Now my advice is this. What you want to do is drag this line, pop the subtraction or addition sign up to the top, and don't do any kind of distribution until you do that. I know it adds a step, and for some of you, you may not need to do that, but it's going to save some of you some headaches when it comes to distribution. So what we have there is we have a FOIL that we need to take care of. Right here what we have is we have a distribution of a negative we have to take care of. And then on the bottom, don't really do anything with these. You can just leave them as bubbles. You don't need to expand out. We actually want to leave them as bubbles because if I simplify, there may be another opportunity to do some type of simplification. Now, be very careful right now. I see students that a lot of times will do this. Boom, yeah, I got x minus 3 on top and bottom. I'm going to cancel. Now, wait. There's a subtraction sign here. So this 2x and this bubble right here is a term. There is no x minus 3 over here in this term. I haven't factored. I factored over here, but I have not factored over here. And remember me saying, no factor, no cancel. You cannot cancel those x minus 3s because this is part of a term, of a binomial term, or once we expand, you can see it's maybe even bigger than that. And so let's go ahead and FOIL here. We have 5x squared. And so I'm going to go fairly quickly here on this one. So 10x minus 2x minus 4. Then here, make sure to distribute your negative 2x. That's going to be, some of you may get tripped up on that, so make sure that you notice it's a negative. Combine your like terms. So this is the numerator, is what we have going on here. So the denominator I'm not going to do anything with. So I look for like terms. I'm not moving anything. They're all together. So I have 3x squared. I have 8x here plus 6x. That's 14x. And then I got a minus 4 left behind. Okay, and then on bottom what I have is I have all this stuff still there. Now, you would think that we would be done, and a lot of times we will be, but what we need to make sure to do is always look to see if we can factor. We're factoring fractions all the time. So what we need to do is look at 3 times negative 4, which is negative 12, and ask ourselves, could I factor this trinomial? Do I need to do bottoms up? Can I find factors of negative 12 that add up to 14? Well, 6 and 2, 4 and 3, 12 and 1. What you'll notice is there are no two numbers that will fit. And so for this problem, we sort of lucked out a little bit, and we can't go any further, no factor, and since we can't factor, we can't cancel anything, and this would be appropriate at that point to leave your answer looking like that. So I'll move this red thing and let you take a look at the answer down there at the bottom, and what you'll see is that we have the exact same answer, identifying the undefined values of negative 2, 3, and 2 out to the side is what we'd want to do, especially when we do equations. That's going to be key. Okay. Let's take a look at another one that uses addition and subtraction both, and we'll move on to multiplication as well. So what we need to do is always with fractions, we do what first? Factor fractions first. And so what we want to do is we want to go ahead and factor this trinomial, that trinomial, this trinomial, and that difference of two squares. These two are prime. So I know I'm going fairly quick, but this is where you can pause actually if you need to, and make sure that you understand where I'm getting all these factors from. This is factors of negative 6 add to 1. So what you'll notice is negative 2 and 3 multiply to be negative 6, but add up to be positive 1. On the bottom, same kind of thing. So it's a shortcut trinomial, and then what we get is we get negative 4 and a positive 3. So you can sort of see something right there. So we're going to come back to it. We're not there yet. Don't simplify yet. Here's the tricky one. This is the bottoms up. And so we're going to do A times C. So that's negative 20. I want to find factors of negative 20 that add up to positive 1. And so you go, well, it's positive 5 and negative 4. And so what you do is you create your double bubbles. And when you create your double bubbles, don't forget to put your A underneath your factor, or A is 2. And so we get to this point, and then over here, we get that one. And then on the bottom is the difference of two squares. And so it goes to our templates. And so it goes x plus 4, x minus 4. So right here what we want to do is bottoms up, because we can't reduce 5 over 2. Now 4 over 2 we can reduce to 2. And so this is going to cancel and just go to 2. So what we have now, I'm just going to erase this for, that's going to be a 2. And this one's going to be 2x plus 5, because it bottoms up. Okay, so you always look to reduce. That's what we did over here. On this one, we couldn't reduce. And so what we need to do is we need to take the 2 and bring it right up here. And so we get 2x plus 5. I mean, you can FOIL that, and it works. It's going to get you right back to that trinomial that we're dealing with. You do want to be careful with subtraction, at least be aware of it. But before we do anything else, let's go ahead and evaluate where it's undefined, and that is where the denominator equals 0. So I have an x plus 4. Where does that equal 0? Well, at negative 4. Okay, x minus 4 is another denominator I've got to consider. Well, that would be 4, so x cannot be 4. Oh, x plus 3 is another one, so I got 3 of them right now. And so you got x cannot equal negative 3. These two I've already done, so I'm not going to do them again. So here's our 3 undefined values. These are not our solutions, they're just where it's undefined. Now my objective is to create common denominators for all 3 of these fractions. And so you see, oh, this one has an x plus 4. This one has an x plus 4. Guess what this one needs? You're right, an x plus 4. So you're going to multiply in an x plus 4 on top and bottom. Now all 3 of them have an x plus 4. Now, before I go too much further, I almost forgot this again. We mentioned we have this x plus 3 here. Look, if you can vertically cancel at any point, do it. And so right now we can do that, and then it takes that that denominator out of the problem now. Now all we need are x minus 4s. This one has an x minus 4. This one has an x minus 4. This one needs an x minus 4. It saves us so much trouble if we can identify that vertical cancellation early. Otherwise, you're going to have a tremendous amount of multiplication to do. You won't really want to do that. It would still work out eventually, but man, it would be a lot of work for you. So now what we have is we have x plus 3 and we have x minus 4 up here. I'm going to now squish these and squish these together. I've got my common denominator. Okay, my common denominator is, it's not very big, it's the top that's going to be really big, x minus 4, x plus 4. That's what we have in the denominator. So the numerator is going to be x plus 3, x minus 4, then a plus sign, and then I've got x minus 2, x plus 4, And then when I got the subtraction sign, and then I've got this foiling left to do over here. So again, I got to be careful on that. Okay, so that's where we're at. We got a lot of foiling left to do. I've got foiling here, and distributing a negative. I've got two things here left to do. Once I do that, combine all like terms, and then look to factor again. You'll always look to factor. And so what we're going to get is you're going to get x squared. And then over here, I'm going to go a little quicker again. So it's going to be minus x minus 12. In the middle, you're going to get a positive x squared. Then you're going to get a positive 2x. And then you're going to get a negative 8. That's what you would get when you FOIL. Again, what I'm doing is just simply FOILing 4x minus 2x is 2x. That's how I got that. And then negative 2 times 4 is negative 8. Now this one you want to be careful. We're going to deal with the negative here in just a moment. If I go ahead and FOIL this, I'm going to FOIL it up here. I get 2x squared minus 4x. There's your minus 4x plus 5x. So that's going to be a positive 1x. And then minus 10. Now that is what the bubbles created. I have to take this negative and subtract that entire product. So I'm going to go ahead and change the signs of all this because I'm subtracting each one of those terms. So that ends up being my numerator. Woo! That's a long one. So now it's like, oh, let's go ahead and combine like terms. Now look what happens though. You got x squared plus x squared. That's 2x squared. What's 2x squared minus 2x squared? Nothing. Okay, so that eliminates the x squared. Now what we have is we have 2x here. I take away 1x and I take away a second x. Guess what? X's are gone. This is working out pretty nice. Now what I have is negative 12 minus 8, which is negative 20 plus 10. Negative 20 plus 10 is negative 10. So my numerator is simply negative 10. My denominator is x minus 4, x plus 4. We have all of our undefined values listed out to the left over here. And so now all I got to do is just check my answer. And yay. Now they went ahead and FOILed the x minus 4, x plus 4. You don't have to do that. But if you wanted to, you could. And then they have the undefined values as well. And so that is another example using addition and subtraction. Moving on to multiplication, I think these are a little bit easier. They go a little quicker. What we got to do is they're fractions. So what do we do first? Factor fractions first, the triple F. And so again, what we have here is we have x plus 3, x minus 1. That's factoring. You've got a lot of trinomials. Hopefully that you're feeling a lot of confidence in that. Then you have x minus 2, and again, there's nothing I can do with x minus 2. However, I can do something here. It's x plus 4, x minus 1. That gives me negative 4 and a positive 3. With multiplication, now we do need to identify where it's undefined again. So that's setting each denominator equal to 0. So it's a great habit to get in. And so we go ahead and we get negative 2. And then the x plus 4, we get negative 4. And then with the x minus 1, we get positive 1. Okay, that it doesn't equal. So we've identified the three values that's undefined. Now what we can do is look to vertical cancel, any vertical cancellation, or cross cancellation. So I look and I say, look, x minus 1. I can remove that. It doesn't look like there's any other. These two are not quite the same. And so if I go ahead and I do our traditional multiply straight across the bottom. Now keep them bubbles right now. Okay, because you won't have to FOIL this. You can just leave it as bubbles and that would be perfectly fine. A lot of times simplification means gets rid of bubbles. But we're going to be okay with it leaving it like that. There are no factors on top and bottom. And so what you get, and you can see the answer down here is going to be the same as what we have. X plus 3, x minus 2, x plus 2, x plus 4, and your three undefined values listed out to the right. So pretty nice stuff. That's a little bit more easy to handle than addition and subtraction. Now, if you look at division, we don't really divide fractions a lot of time. What we do is we convert this to a multiplication. So division is the reciprocal of multiplication. In other words, dividing by 2 is the same thing as multiplying by 1/2. And what we need to do is keep the first fraction, change this to multiplication, and flip the second fraction. Now, before we do all that, what do we do when we have fractions? We factor fractions first. So again, a lot of trinomial stuff on these examples I'm giving you. X minus 5, x plus 4. On the bottom is just 2x. There we go. And then over here, what I'm going to do is I'm going to change it to multiplication. Okay? Keep it, change it, flip it. So the 6x cubed goes on top. On the bottom, I'm going to go ahead and factor that, and that's going to be a perfect square trinomial, x minus 5, or x minus 5 squared. And now what we can do is we can look to vertical cancel or cross cancel. Now, x minus 5, most students see that one first. There's nothing, I can only get rid of one of them, okay? There's no other x minus 5s. However, 2 and the x are both factors. 6 and the x cubed are both factors. So I can cancel the 2 and the 6, leave me with the 3, leaves me with the 1 down here, and I can cancel this 1x with one of those 3. Leaves me with 2 x's there. So I actually have 3x squared there, and I have x plus 4. So I have 3x squared and x plus 4. And then on the bottom, all I have left, oh, this whole thing's gone, that's gone, so it's just x minus 5. And we've identified where it's undefined. No, we didn't do that. We should have done that. I sort of skipped that, but let's do it right now. This denominator we'd set equal to 0, and x cannot equal 0 once you divide by 2. X minus 5 cannot equal 0, so x cannot equal 5. And then x minus 5, we just did that one, so we're going to get the same answer again. So it can equal 5. And so what you'll notice here is we got 0 and 5, what it cannot be equivalent to, and that matches up with the answer we got. Okay. Now repeat, you can go back and rewind these if you're not sure exactly. Slow things down, pause it, go back, look at more examples. It'd be great to do if you find yourself getting stuck. Moving on to complex rational expressions. Now what a complex rational expression is a fraction inside of a fraction. Is what it is. And so what we have is you can see some examples. Now this one you can definitely tell the fraction inside of the fraction. So that's called a complex rational expression is what that is. Now this one doesn't look as much like it. And we got to be very careful with these negative exponents. Most students remember, oh, negative exponents, we flip it. But it's not going to go down here with this x. This is a single term. It flips with inside itself. So it flips with inside a term. So technically that first one would be 1 over x minus 1 over y all over x. So we have fractions inside of one big fraction is what we have. And that's called a complex rational expression. Now what our goal is here is we want to make this look simple. Okay? We want to make something very complicated look easier. A lot like what we did in those previous sections. In math, if we can make something complicated look easier, why wouldn't we want to do it? And so how do we do this? Well, what we want to do is we sort of want to go ahead and ignore the denominator for a time. Like it's not even there. And what we want is we want one single fraction in the numerator. So we want to squish those together so that I have one fraction in the numerator. Then what we'll do is we'll do the same thing. We'll ignore the numerator and make sure the denominator is one single fraction, which in this case would be x over 1. Okay? Now once you get to this point, don't we have a fraction divided by a fraction? And when you divide two fractions, what do? Well, you keep it, change it, flip it. Okay? So all we're doing with complex is making it one single fraction over one single fraction so that I can go ahead and divide two fractions. Okay? So let's look at one right here. Similar to the second example you just saw on the previous screen. What we want to do on a problem like this is we want to go ahead and start off and say, look, let's ignore the denominator of this complex fraction. And let's just simplify the numerator. And so here, now be careful. A lot of students go, well, can I just add z like that to both? Unfortunately, that does not make the fractions equivalent. A good example of that would be this. If I added 1 to the top, that's 1/3 is what we started with. And if I do this, I get 2/4, which is 1/2. Well, 1/3 and 1/2 are not the same. That is not a property. I cannot just add things in. I got to multiply them. So first things first, they're fractions. We factor first. There's nothing I can factor there. I like putting bubbles around to show the prime. X is also prime. So this one needs an x plus z. So whenever you do the bottom, you got to do the top. Be careful of your negative. This one needs an x. Okay? So now if I squish this together, I got x minus the bubble, x plus z, all over x plus z. Now the numerator, I want to go ahead and distribute my negative. That's why I said be careful. And what you'll notice is the x's are going to cancel, and I'm left with just negative z on top, or the opposite of z would be a better way of saying that. And then that's my denominator. Now remember, this is just the numerator of the complex. Now what we want to do is we want to go ahead and ignore the numerator and go, okay, what's the denominator look like? Well, it's z. And technically it's z over 1. I like writing it like this so you guys can see the fractions. Because now what we have is we have a fraction and we have a single fraction. That's what we wanted, one single fractions on top and bottom. Fractions mean division. So this means the same thing as division. So this divided by that is this actually times the flip of that. Keep it. Change it. Flip it. And now you can look to vertical cancel or cross cancel. And hopefully you notice that we can cross cancel the z. Now don't forget there's a -1 there still, because that negative's still holding true. So what we have is then you multiply straight across the top and bottom. You have -1 times 1, which is -1. And then on the bottom you have x and x plus z. That's what you have there. So if you take a look at our solutions here. Now we didn't really address where is it undefined. That again probably is important to do. Well, first off, z cannot be 0. That you can see that right there. That's in a denominator. If you look back up here, x cannot be 0, and then really x and z cannot be opposite of each other, which just means that x plus z cannot equal 0. We don't know what x and z are, but we know that this cannot equal 0. Because that makes that little denominator 0. So we've identified where it's undefined. A lot of times on the assignment, all they're looking for is going to be that part right there. But it's still good practice to identify where it's undefined. Moving on, looking at one with the negative exponents. Okay, definitely get this one recorded in your notes. It's a little trickier than the one, but it's not still not too bad. What we have a tendency to want to do is flip these down to the bottom, these to the top. And this can only flip with inside of a single term. So with inside of itself is what we have going on. So it's going to look like this. The bottom's going to be the same way, but it's going to, so that's where you'd have to go. And I don't, it'd be great if you could make it there. If that's what you were thinking, perfect. If you weren't, make sure to get this recorded, review it, see if you can understand. I flip what's inside of itself. This is a double term. I can't bring it down here, move that up there. Unfortunately, that doesn't work. Now what we want to do is we want to go ahead and we wanted to ignore the values on the bottom. And so we want to go ahead and ignore those. Let me go ahead and put this all the way to the top layer. Okay, and that way you can not see the bottom very much. And so what we have is we want to squish these two together. So I need common denominators. And so I need a y there, I need an x there. Now I can squish these together. I get y minus x over xy. Okay, there's my numerator. I got my line. Now I got to figure out the denominator. Okay, and so we go ahead and we take a look at this. And we go, okay, well, how do I squish these together? Well, I need an x squared here, and I need a y squared there. And now I can go ahead and squish them together, and I got y squared minus x squared over x squared y squared. Woo! Hey, now, where's it undefined? Well, it's undefined when x is 0 and y is 0, so you can see that from our fractions here. And so you can, let's just put that out to the side for right now. And then what we got here is we've got to keep it, change it, flip it. But don't forget, with fractions, we always got to be looking to factor. And so there is some factoring going on here. Let's take a look at this real quick. Keep it, change it to multiplication, and then if we flip it. So most students are seeing this cancellation between those two. But it's this one right here, the y squared minus x squared. Hopefully you notice that's the difference of two squares. This can be factored to be y plus x, y minus x. So you're like, sweet! Because this one's prime, cancel, cancel. There's my cross cancellation that maybe we didn't see initially, but hopefully we can see now. Then I can cancel this x with one of those, this y with one of those, and how can I do that? These are factors because it makes a product. These are factors because it makes a product. I can cancel factors. I cannot cancel terms. I cannot cancel that y with one of those y's because that is a term connected with that subtraction sign. Do not cancel terms, only cancel factors. So what we have is xy on the top. This is gone. All we have is y plus x on the bottom. I cannot cancel those x's or y's because guess what? Those are terms. Okay, you can only cancel factors, not terms. And we got the same answer. Now the y minus x and the y plus x, why are those? Why would those be? Well, right here, if you take a look, those are in the denominator, and so that's why those couldn't equal 0 as well. So again, for the assignment and on the test, this is really what we're looking for. This is great practice to get you ready for the equations, okay, is where it's undefined. Okay. Speaking of equations, let's go ahead and jump in. Solving rational equations. Well, what do we got to do first? If it's a fraction, remember rational means fraction. If it's a fraction, what do we do first? Well, we factor fractions first. That's what we do. And so we go ahead and we factor first. Then we need to identify all the undefined values. Now, the undefined values of fractions are where the denominator equals 0. Where the denominator equals 0. Okay? Document to the side to check with our answers later. So everything that we've been doing up to this point, we're going to do the same thing. So you're going to record x cannot equal whatever number we decide the denominators are equivalent to. So record all those. We're going to check them with our solutions here later. Then what you want to do with equations, and there's a lot of different ways you can do this, but this is the way I'm going to teach it to you, is that we're going to go ahead and create common denominators, because that's what we're used to when we add or subtract. So create common denominators all the way across the bottom of the equation. So remember, whatever you do at the bottom, you got to do at the top. So we've seen that. We did it with addition and subtraction. And so what we want is create all these denominators to be the same. Once the denominators are all the same, and once we've identified where it's undefined, if all the bottoms are the same, that means all the tops have to be the same. And so what we're going to do is we're going to use this thing called the Snoop Dogg rule. Okay, this is not out of your textbook. This is a little bit made up. But hopefully this gives you an understanding of what we're doing. If all the bottoms are the same, then that means all the tops have to be equivalent to each other. And so we can get rid of them, and I'll show you why in the next slide. Solve for the unknown is at that point, and then make sure to check your answers with the values you found up here, because there are possibilities that you've done everything right, and you find an answer. Unfortunately, it's an undefined value. And so a lot of times we call these extraneous solutions. You've seen that word with absolute values or with radicals. So sometimes you do nothing wrong, it just doesn't work when you plug it back in because it's undefined. Now what is this Snoop Dogg rule? Now the Snoop Dogg rule is once you create common denominators all the way across the bottom, what do you think we're going to do? Well, if you remember from Snoop Dogg, anytime that you get common denominators, there we go. You're going to drop it. Okay, you're going to drop the denominators all the way across the bottom. So once all the denominators are the same, you can get rid of them and just solve across the top. Makes your life so much easier. Again, there's other methods of using LCMs and things like that, but I like using the Snoop Dogg. Seems to sort of hit a chord with students. So let's sort of see this in action and sort of see if we can get the right answer. So let's look at this problem right here. Now, first off, it's fractions. What do we do first? We factor fractions first. What do we look for first when we factor? GCF. So if you notice here, there's a GCF. There's a GCF in that one. This one doesn't, that one doesn't, but those other two do. So the first thing we do is always look for a GCF, and we take an x squared out, and we have an x plus 6. So there's your numerator of that one. Over here, I can take a negative 2 out. Really, to be honest with you, it's the denominators I'm most concerned with, but it's good to go ahead and factor the top, just in case maybe there's a vertical cancellation that we don't see from the beginning. So if we go ahead and factor the denominator over here, we have x plus 6, x minus 2. It's a shortcut trinomial. Oh, that's what I'm talking about. Okay, that x plus 6 is going to cancel. And then you have x minus 2 over here. So this is going to work out really nicely. And hopefully we'll look at another example where we have to do a little bit more work. First things first, though, before we do any kind of Snoop Dogg, we got to identify where it's undefined. It's going to be undefined when x minus 2 equals 0, so at 2. And then when x plus 6 equals 0, which is at negative 6. Okay? So we've identified, this is important. Make sure to record this out to the side. Now what we can do is on this one, see ya, x plus 6, we can vertical cancel. We can't cross cancel because it's not a product at this point. It's an equal sign, but we can definitely vertical cancel at any point. So now what I have is, if you notice, don't we have common denominators at this point? I mean, if you look at the two fractions that we have the same denominator for both sides of the equation. Everything looks the same. Well, Snoop Dogg says go ahead and drop it. I mean, we've already recorded where it's undefined. If the bottoms are equivalent, that means the tops have to be equivalent. There's your dead giveaway. It's a quadratic. Okay, we just recently been taking a look at those, so that's a quadratic. So I'm going to distribute back to negative 2, set all quadratics equal to 0 when we solve, and I really hope we can factor this, and it looks like we can. We can go x plus 4, x minus 2 equals 0. Use your zero factor property, and you end up getting 2, and you get negative 4 as solutions, and we shout for joy, and we put that in, and we miss it. Why in the world did I miss it? Well, look at where it's undefined again. We have to compare our answers. The negative 4 is perfectly fine, but look at 2. 2 is not a solution. It's undefined at 2. I can't plug in 2. Try plugging 2. You get 0 in the denominator. The worlds are colliding. We don't want that. We want to avoid that at all costs. So really the only answer we have here is a negative 4. And so you can see two answers, but one of them has to be removed because it's undefined at that value. Moving on to the next problem. Okay, a little bit different. You have a few ways you can do this. You can actually move the 1 over and do some things, or you can just leave it where it is. Let's just go ahead and leave it where it is. I think it's good practice with the distribution of a negative. So first things first, I got to factor. The bottom cannot be factored. It looks almost like the difference of two squares, but the x is not squared. I cannot write that as something squared. And so there's sort of the rest of them. I know we write 1 as 1 and 0 as 0, but I wanted to show you the denominators. So what we need to do is identify where it's undefined. It's undefined at 1/4, and I set this equal to 0. From there, I want to create common denominators. So what I'm going to do is I need a 4x minus 1 here, and a 4x minus 1 there. And we need the same thing there. And that really doesn't change anything, but we do it anyways. So now notice all the denominators are the same. What can we now do with rational equations? You can't do it with expressions. With equations, though, you can use the Snoop Dogg rule and say, now I can go ahead and I can drop the denominators. Once they're all the same, they can just vanish. Now what we have here is we have 2x squared minus the entire quantity. Notice I'm subtracting the entire quantity, distribute that negative through. And then 0 times anything 0, it's a quadratic. Now this quadratic, if you try to go ahead and factor, 2 times 1 is just 2. There are no factors of 2 that have to negative 4. So this is the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so what we end up getting, as quick as I can here, we end up getting 8, square root of 8 all over 4. And the square root of 8 actually can be simplified down. You can take a 2 out and leave a 2 behind. So if you need some review on that, make sure to talk to me. At this point, notice, okay, we have 2 terms on top and we have 1 on the bottom. It's an STD. You could stack and simplify, or just look. Don't we have a 2 common in every term? That means there's a common factor, and I can only cancel factors. So I can't do this unless there's something here I can also remove. And so notice there's a 2 common in all of them. And so I can take a 2 out, and that's as far as I can go. You cannot cancel those. That's a term, not a factor. That's as far as you can go. That definitely is not 1/4, so I should be in pretty good shape. And there's your 2 answers. 2 plus the square root of 2 over 2, and 2 minus the square root of 2 over 2. And you can check all these. Keep that in mind. There are equations. Okay? All right, last thing, work rate problem. Okay? Hang in there with me. We're almost done. And a work rate problem, 2 or more workers are acting in unison or against each other. I mean, they could be working against each other, which means subtraction. When they're working with each other, then it's addition. So what this means is we have like 2 people painting a room. And if you know the rate of each person, how long it takes them to paint the room, you can calculate how long it would take for both of them working together. Or let's say you're filling a swimming pool with multiple water hoses. Something like that. And what we're using are rational expressions. And so there's a little bit of a formula down here at the bottom that you want to be comfortable and familiar with. And that is our rate equation. So you have rate 1, which is 1 over the time. Rate 2 is 1 over time. And then together's rate is 1 over time together. You would add those two together. If they're working with each other, it would be additive. If they're not working with each other, it would be a subtraction. You would take the, let's say, the quicker rate minus the slower rate, and then that would tell you how long it would take. So if you had like a leak in the pool while you're filling it, it's probably going to fill, but it's going to take a lot longer because you have something working against it. So 1 over x, 1 over time is what we're looking at. So here's a good one, and this is what I was talking about, a hose for a swimming pool. 1 hose can fill a swimming pool in 10 hours. So what's its rate? Well, 1 over the time. That's its rate. And then the owner buys a second hose and can fill the pool in half the time, the first one. So what's half of 10? Well, it's 5 hours. So what's that rate? 1/5 is its rate. And so if they're working together, then how long does it take? Well, 1 over x is the rate. So we're looking for x. X is the time. Because remember, it's 1 over time together. So this is technically what we're trying to figure out. That's the question they're asking us. So what we want to do is go ahead and get common denominators, squish them together, and then at this point, you can go ahead and cross multiply. Okay, for this problem, and then divide by 3, and there you go. You can also go right here and just always do the reciprocal. 3 over 10 is going to be 10 over 3. Just flip both sides. You can do that. Okay, just got to flip both sides of the equation. That would make them equivalent to each other. And so x would equal 10 over 3. And so what we have is how long would it take? Just over 3 hours. 3 1/3 hours is what it would be. Okay. Moving on to another problem. The same pool owner, the last example, fills this empty pool with the 2 hoses. And so we already know that rate, wasn't it? It was 10 over 3, or excuse me, it was 3 over 10 was the rate. 10 over 3 was the time. But 3 over 10 was the rate of the 2 hoses, so 1/5 plus 1/10. However, if you take a look here, but accidentally turns on the pump that drains the pool. The pump rate is slower than the combined rate of the two hoses. So this is the faster, this is going to be the slower, but it takes 20 hours. So what's its rate? 1 over 20. It's working against it, so I need subtraction. Now the question is, at what rate? So it's not asking for x, it's asking for the rate. So it's asking for 1 over x. So this is a little bit easier. All I got to do is get common denominators, and then go ahead and do this, and you get 5 over 20, which is 1/4. And 1/4 is the rate. Now, how long would it take? Well, it would take 4 hours instead of 3 and 1/3. And so 1/4, though, is the rate. Your x is 4, that's your time. But what is the rate is what they're asking for. So technically on this one, x is 4, but your rate is going to be 1/4. And that's what they're looking for. At what rate can the pump empty the pool? It takes 4 hours for it to fill the pool. I think on this one it probably needs to be to fill the pool instead of to empty the pool. Pump to fill the pool. Okay, so a little bit of error there. Okay, and that's it. That is a work rate problem. You'll have people painting rooms, two sisters painting rooms, working with each other. You'll have a stream feeding a lake and maybe a dam that's opened up, and that will be working against each other, or maybe two streams feeding in, and they'll be working with each other. You just need to remember this is your formula. Okay, and these are your time. X's are your times. This is your total time. This is the time of each one. If they're working against each other, it would be subtraction. Okay, hopefully you pick some of that up in 2.5. Thanks for hanging in there. We're moving on to the next one.